This problem showed up on my YouTube homepage a couple of times, so I thought I'd show how to do it. It can be really simple or pretty complicated. The question is, if you have 5 machines that can make 5 donuts in 5 minutes, then how long will it take 100 machines to make 100 donuts? I'll show the wrong way of thinking. This is what I initially did, and I think most people might do this. If you can make 5 donuts in 5 minutes, then that means 100 donuts would take 100 minutes. But the problem with this thinking is this assumes you're making the donuts sequentially or one after another, but you're actually making the donuts simultaneously because you have 5 machines, so you're making them all at once. You can pause the video if you want to think about it for yourself, or I'll show a hint in 3, 2, 1. If 9 women can have 9 babies in 9 months, then how many months will it take 100 women to have 100 babies? 9 months. I'll show the donut answer on the next page. It reduces down to one machine can make 1 donut in 5 minutes. Just think of a little easy bake oven where you can only make 1 thing at a time. So if you have 100 machines, then that means you can make 100 donuts during that 5 minutes. Next page. This forms a complex fraction, which means you have a fraction in your fraction. Then you have to decide in which order your units go. Should it go machine, donuts, minute, or should the donuts be on the top or on the bottom? Or should minutes be on the top or in the middle? And also with a complex fraction, you have a long division sign and a short division sign. If you change them around, you get a different problem. So for example, if we have the long division sign on top, we have 5 divided by 5/5, which equals 5, because that's 5 divided by 1. If you bring your long division sign and put it down here and put your short one up there, you will have 5/5 divided by 5. 5/5 reduces to 1, so you have 1/5. In the end, this is the correct way to set up this complex fraction, and you will be multiplying your numerator by the denominator of your denominator, so it'll look like this: 5 machines times 5 minutes over 5 donuts. It took me a while to figure this out with just trial and error. I kept doing everything wrong for a while. I figure there's 2 wrong ways to set this problem up and 1 correct way. The donuts has to be by itself. Machine minutes go together. So that means you could accidentally bring down your minutes and you could have donut minutes, or else you could have donut machines. So this reduces down to 5 machine minutes per donut, or work per product, which is an economics lesson right there. You could replace machine minutes with man hours. So for example, to build some large building or program a video game, that takes thousands or millions of man hours. Play around with this ratio if you want to. Put units in different places, put your long division sign in different places and your short division sign in different places just to see what happens. That is, if you want to. You'll keep getting the wrong ratios and the wrong answers. Now that we have our ratio here, 5 machine minutes per donut, or work per product, we can use this ratio to get our answer, and you can always invert your ratios depending on what you start with. For example, here I'm going to start with 100 machines, which means I need to invert this fraction. Remember in the original question, it asks how long does it take for 100 machines to make 100 donuts? So that means I have to start with 100 machines, or 100 donuts. 100 machines, 5 machine minutes per donut. Machine will cancel out with machine. We'll be left with donuts per minute, so we can make 20 donuts per minute. Remember, with our Easy Bake Oven, you can't make a donut in 1 minute. It takes 5 minutes to make a donut. So this is a little bit tricky here, but it's just an average. On average, we're making 20 donuts per minute if we have 100 machines. And again, make sure everything's set up so that the correct units will cancel out and you're left with what you want, which is donuts per minute. Now we can use this ratio for another conversion equation. We don't want 20 donuts, we want 100 donuts. So 100 donuts, 20 donuts per minute. Donut divided by donut cancels. We're left with 5 minutes, which is the final answer. And this is the short way to do this. I started with machines here, so now I'm going to show that if you start with 100 donuts instead of 100 machines, you'll get the same answer, but it'll just require an extra 1 or 2 steps. And I'm still going to use this same ratio right here of 5 machine minutes per donut. Next page. So here's our ratio again, 5 machine minutes per donut. We want to make 100 donuts, and so 1 donut is 5 machine minutes. Donut divided by donut cancels. That means it'll take 500 machine minutes as the amount of work to make 100 donuts. This means it'll take 500 machines 1 minute, or it could take 500 minutes for 1 machine. you just multiply machine times minute, and your product has to equal 500. This means you could have 250 machines and 2 minutes. But since we know that our little Easy Bake Oven takes 5 minutes to make a donut, because we can put one donut in that little oven and 5 minutes later it'll be cooked or baked. If we have 5 minutes, that means we will need 100 machines, and that would be our final answer. Because then we would have 100 machines with 100 donuts that would take 5 minutes. But let's just say we don't know that, so let's take this 500 machine minutes right here and use this as another ratio. So we're given 100 machines in the problem, 500 machine minutes for 100 donuts, 500 per 100. Machine divided by machine cancels. These two zeros on the 100 will cancel out with the two zeros on the 500. And so we will be left with, let's see, machine cancels out with machine. We'll be left with donuts per minute, 20 donuts per minute. And this was the answer I showed on the previous page when I solved it the other way. So now we take 100 donuts because that was the original question. How long does it take 100 machines to make 100 donuts? 100 donuts, 20 donuts per minute from this ratio right here. Donut divided by donut cancels. We're left with 5 minutes. So the same answer. I think this problem is extremely interesting because it appears extremely simple. But when you start looking into the complex fraction, trying to figure out how to organize that, and trying to figure out how to organize all of these conversion equations, it's actually very complicated, so it's almost paradoxical.